Hi friends, in this session we will study about the trigonometry, the branch of mathematics dealing with the relation of the sides and angles of a triangles and with the relevant functions of any angles we study in the trigonometry. So here you see the relations of the sides and angles of a triangles with the relevant functions of any angles we study in trigonometry. Elementary, we apply trigonometry on right angle triangle. Here you see we have a right angle triangle here. We give some name to this. What is this of this triangle? So this is A, this one is B, and this one is C. So we have a ABC triangle. In triangle A, B, C, here angle B is equal to 90 degree. We know here this is a 90 degree. We know that the side opposite to 90 degree angle in a right angle triangle is called hypotenuse. It's called hypotenuse. And by Pythagoras theorem, we know that the square of side opposite to right angle is equal to the sum of square of other two sides in a right angle triangle. So by the definition of the Pythagoras theorem, we see here AC square is equal to AB square plus BC square. Now we see we have given some name to the ratio of two sides with respect to an angle. So we see what are those ratios. First, I mentioned an angle here. We give a name angle A. The measurement of angle A is theta. So with respect to this theta, we have to find out the ratio of sides of this triangle. So the side opposite to the angle what we are taking with respect, we want to give the name to the ratio, is called perpendicular. This opposite side is called perpendicular of the theta. And the side on which theta and 90 degree both lie is called base of a triangle. So we denote perpendicular by small p, hypotenuse by small h, and base by small b. So we give the name. Here we see the first I would like to explain about the ratio. So we have given the ratio of perpendicular over hypotenuse. Just I change the ink of the pen. So the ratio, I put the ratio formula here. But I want to explain you now. These are called the ratio formula. So the ratio of perpendicular over hypotenuse is called sine with respect to theta, and the ratio of base over hypotenuse is called cos with respect to theta, and the ratio of perpendicular over base is called tan with respect to theta, and the ratio of its reciprocal, if we take instead of perpendicular over hypotenuse, we take hypotenuse over perpendicular, so we get cosec theta, and hypotenuse over base we get sec theta, and base over perpendicular we get cot with respect to theta, cot theta. So these are the ratio formulae. Now I want to explain the full name of this cos, sin, tan, this all. So the sin, basically sin is written in this way. Sin, that sin is, this sign is the abbreviation of this sign, and cos, the full name of cos, the full name of this cos is cosine, and this tan we write tangent, and for this cosec we write cosecant, for this sec we write secant, and for this cot we write cotangent. This is the full name of this, or we use the abbreviation. These are the abbreviations: sin theta, sin, cos, tan, cosec, sec, and cot are the abbreviation of this full name. Now I would like to tell you about the reciprocal formulae. Reciprocal formulae we see here. We know that here you take a look of this. It is the P over H, it is the H over P. So the reciprocal of sin theta is cosec theta. Here you see B over H and H over B, both are the reciprocal of each other. So the reciprocal of cos theta is sec theta. Here you see P over B and B over P, both are the reciprocal of each other. So the reciprocal of tan theta is cot theta. So we could write this formula in this way. Sin theta is equal to 1 over cosec theta. Cos theta is equal to 1 over sec theta. Tan theta is equal to 1 over 1 over cot theta. Now we multiply this cosec theta to left side, we get sin theta multiplied by cosec theta is always equal to 1, cos theta multiplied by sec theta is also always equal to 1, and tan theta multiplied by cot theta is also equal to 1. If we cross multiply this sin theta to other side, we get here cosec theta is equal to 1 over sin theta. Here sec theta is equal to 1 over cos theta, and here cot theta is equal to 1 over tan theta. So these are the reciprocal formulae of trigonometric ratio. Now I would like to tell you about the relation formulae. So you see here in relation formulae, first I want to tell you about the relation of tan theta with other ratios. It is sine theta over cos theta. So how we get this? I explain you, because sine theta, we know that sine theta is equal to P over H, and cos theta is equal to B over H, and H and H both are in denominator of the numerator and denominator, so they will eliminate to each other. So we get here P over B, which is tan theta. So we can make another relation here. Cot theta is the reciprocal of tan theta, so we have to just interchange this in denominator and numerator, so we will get here cos theta over sine theta. Now we have two more of this. Tan theta is equal to sec theta over cosec theta. So I explain you how to get this, because we know that tan theta is equal to sine theta over cos theta, or we know that sine theta is equal to 1 over cosec theta, and cos theta is 1 over sec theta. So what we will do here, the denominator of denominator is sec theta will go in numerator, and this cosec theta comes to in denominator. So you see here we get tan theta is equal to sec theta over cosec theta. So in this way we have got this tan theta is equal to sec theta over cosec theta. Now cot theta, because the cot theta is the reciprocal of tan theta, so similarly what we have done here, we have to do the same process here. So cosec theta over sec theta. So these are the reciprocal these are the relation formulae of trigonometric ratios. So in this session we have studied the definition of trigonometry, what is trigonometry basically, and we have seen we have looked that what are the ratio formulae, and we have seen the full name of this ratio, sign and their abbreviation. We have studied about the reciprocal formulae of different ratio, and we have um, seen that relation formulae of different trigonometrical ratio.